Hello students, I am Jaya Bhushan from Department of Mathematics, Patna Women's College, Autonomous. Today we will discuss about basic concepts of differential calculus and successive differentiation. On intermediate level, you were taught differentiation to find the derivatives, that is dy by dx, which is termed as the first order derivative. So if we define y equals to fx, where x and y be two variables such that y varies with respect to x, then we can say that x is an independent variable whereas y is the dependent variable. Similarly, if we define another function z equals to f of xy, then z is called the dependent variable whereas x and y be the independent variables. We always find derivative of dependent variable with respect to the independent variable. In mathematics, the rate of change of a function with respect to a variable is termed as a derivative. There are mainly two types of derivative. First, ordinary derivative, and the second is partial derivative. Let us first understand ordinary derivative. If we have y equals to fx, then ordinary derivative of y with respect to x is denoted by dy by dx and is defined as limit h tends to 0 f of x plus h minus fx whole divided by h as shown in the graph here. It consists of one or more functions of only one independent variable along with their derivatives and is also denoted by y dash, f dash x, y1, d of fx or dy. For your reference, a list of derivatives of some standard functions is given here. Like on differentiating y equals to k, where k be any arbitrary constant, we get dy by dx equals to 0. Then differentiating y equals to log x, we get 1 by x as its derivative. Then here we have derivatives of trigonometric and inverse trigonometric functions. With the help of these formulas, we can solve problems of differential calculus. There are certain rules followed to find derivatives of a given function. We apply product rule to find the derivative when two or more functions are given in the product form. For example, if we have y equals to x to the power 4 into sin x, then its derivative will be y dash equals to 4 x cubed sin x plus x to the power 4 into cos x, which means its derivative is calculated as the sum of the first function multiplied by the derivative of the second and the derivative of the first function multiplied by the second function. Then we use quotient rule to find the derivative of a function which is in the ratio of two differentiable functions. For example, if we have y equals to 5x upon sin x, then its derivative is calculated as the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator and whole divided by the square of the denominator. That is, here y dash equals to sin x into 5 minus 5x into cos x all divided by the whole square of sin x. We proceed with chain rule, also known as outside inside rule, to find derivative of composite functions. That is a function which is the composition of two differentiable functions. It is calculated as the derivative of the outer function while keeping the inner function same and then multiplying this by the derivative of the inner function. For instance, if we have y equals to cos 3x square, then its derivative will be y dash equals to minus sin 3x square into 6x. Further, we will talk about successive differentiation. It is a method of deriving higher order derivatives from a given function by subsequently differentiating it, and the results obtained in the process are called the successive derivatives. Its applications are widely spread in physics. Like in mechanics, the velocity time graph. The slope of this graph gives the acceleration. So we can find the acceleration by differentiating the velocity with respect to time. It is also used in life sciences domain to relate the concentrations of drugs in various body organs over the time. Moving forward to higher order derivatives, let us consider a function y equals to fx which is differentiable up to nth order. Then its first order derivative with respect to x is denoted by y1 or f dash x. Second order derivative of y with respect to x is denoted by y2 or f double dash x. Similarly, third order derivative of y with respect to x is denoted by y3. Similarly, we can also find derivative of the given function up to nth order, and so the nth order derivative of y with respect to x is denoted by yn or fn x. Let us take an example here. To find nth derivative of y equals to e to the power ax, we will differentiate the given function with respect to x, that is y1 equals to a into e to the power ax. Differentiating first derivative with respect to x, we get the second derivative, that is y2 equals to a square into e to the power ax. Similarly, we get y cube equals to a cube into e to the power ax, and then y4 equals to a to the power 4 into e to the power ax. Further differentiating up to nth order, we get yn equals to a to the power n into e to the power ax. Here you can see nth order derivatives of standard functions which will be used to solve problems of successive differentiation. Taking another example, to find nth derivative, y equals to a to the power x. Differentiating given function with respect to x, we get first derivative, that is y1 equals to a to the power x into log a. Differentiating the first derivative with respect to x, we get second derivative, that is y2 equals to a to the power x into log a whole square. Similarly, we get third derivative, then the fourth derivative. Further differentiating it up to nth order, we get yn equals to log a whole to the power n into a to the power x. Here I would conclude today's lecture. So that's all from my end. Hope you have find it useful. Thank you.